Hello, in this video we're going to go through some of the acid-base problems from the finals review packet. So these are problems 58 and below. So first problem we're going to look at here is problem number 58. Whoops, sorry. And we're going to look at the chemical equation, trying to figure out if a substance is going to be an acid, a base, or neutral. And the key thing to know here is that things that are neutral, so water is neutral, okay? And water is going to have equal amounts of hydrogen and a hydroxide. That's what makes it neutral. Things that are acids are going to add hydrogen to the solution. Things that are bases are going to add hydroxide to the solution. And if something doesn't affect the hydrogen or the hydroxide, then we just say it's neutral. So what we want to do is we want to look at these compounds and look at what ions they're made of. So this right here, barium hydroxide, it is made of the ions barium, and it's made of 2 hydroxide ions. So it looks like when I put this thing in water, it's going to generate hydroxide, making it a base. B right here this is made of hydrogens, and it's made of a carbonate ion. And since this thing has some hydrogens in it, it is going to be an acid when you put it in water. Right here, this is made of hydrogen, and this other thing, ClO3-, this is another polyatomic ion. It wasn't on the list of ones we learned, but it's another one. And notice how it makes some H+, so it's going to be an acid. Notice how our acids tend to begin with H, if you look at the chemical formula there. All right, sodium chloride. When it's made of the ions sodium and chlorine. Oh, there's no hydrogen, there's no hydroxide, so this is actually going to be neutral. And then water, you can think of water as being made of H and OH, as we've experienced when we're thinking about neutralization reactions. So water has equal amounts of H and OH, so it is also neutral. Okay, so we look down here, number 59, we've got these equations that we want to be comfortable with using. Whoops, I wrote that the wrong way. The H+ concentration is 1 times 10 to the negative pH. The OH- concentration is 1 times 10 to the negative POH. And then pH plus POH equals 14. These equations are all going to be given on a test. You don't have to memorize them. You just have to be able to use them. So if I look right here, the hydrogen ion concentration is 1 times 10 to the negative fifth. Okay, well this equation right here tells us that that exponent is the pH. So this thing is going to have a pH of 5. Okay, I just looked at that exponent. And this is an acid because acids have pHs below 7. Okay. Here I've got a hydroxide concentration, so that means that that number 12 is actually the POH, and I can use pH plus POH equals 14 to tell me that the pH of this substance would be 2, and then this is also going to be an acid because the pH is also below 7. So we're trying to judge whether something's an acid, base, or neutral. Make sure you're looking at the pH and not the POH. Okay, so read the problem carefully. Okay, which has a larger H+ concentration, a solution with a pH of 9 or one with a pH of 2? Well, we know that lower pH means it's more acidic, which means it's going to have a higher hydrogen concentration. So pH of 2 is the right answer. Another way of looking at it is using the equation we talked about before. Whoops. If something has a pH of 2, that means the H concentration is 10 to the negative 2. If something has a pH of 9, then its H concentration is 10 to the negative 9. Let's write this out in what we call standard notation. That is 10 to the negative 2 looks like this. 10 to the negative 9 looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is a bigger number. And if you wanted to figure out how much bigger it is, you could plug this in your calculator, 0.01 divided by 0.000000001, and you would find that it's 10 to the 7 times bigger. So it is way larger. So remember, the pH scale is logarithmic. So every time your pH changes by 1, the H concentration changes 10 times. It's a tenfold change. Okay, here's some neutralization reactions. Remember, these are what we call double displacement reactions, meaning the first elements switch places with each other. So K switch places with H. So K is going to go with CO3, and then H is going to go with OH, and you say, oh, hey, wait, that's water. So water is always going to be a product of a neutralization reaction. Sorry, that's kind of messy. The other compound is called the salt, and when you're trying to figure out the formula of the salt, you need to look at the charges of the ions and do our crisscross method to make sure we end up with the right chemical formula. So it's going to be K2CO3. And then we'll discover that, well, now this equation needs some balancing. So I'm going to have to put a 2 over here to give me 2 potassiums on each side. And I put a 2 over here to give me the right number of H's and OH's on each side. Okay, so let's try that one again. The calcium and the hydrogen are going to switch places. So the calcium goes with the chloride, and then the H goes with the OH to make water. Okay, when you're looking at your salt, which is the compound that is not water, we call this a salt. You have to look at the charges of the ions and do your crisscross method. So 2 goes down here, the 1 goes down here. We typically just don't write the 1. And then here's your formula there. So the salt is calcium chloride, CaCl2. And now I need to go back and balance it. So I need to make sure I have 2 chlorines on each side. But now I need 2 hydrogens and 2 hydroxides over here. So now I'm balanced. I have another video where I talk through this in more detail if you want to look back at that one as well. So here I'm going to have my, again, I've got my hydrogen and my sodium switching places. So my, let's see, my sodium is going with sulfate, and then H goes with OH to make water. So you always make water. And then with your salt, we're going to look at the charges and do a little crisscross method. So the 2 comes down here, the 1 we just don't write. And so here are our products, Na2SO4 and H2O. And again, I need to go back and balance it. I need a 2 here, and I need a 2 over here. So those are my neutralization reactions. And then D, we can do some calculations once we have a balanced chemical equation. For example, down here, if you had 8 moles of NaOH, how many moles of H2SO4 would you need? Okay, so this is a mole ratio question. So I'm going to look at my balanced chemical equation. And since moles NaOH is what I have up here, that's the unit that's going to go on the bottom of my fraction. The unit that I want is going to go on the top. So moles H2SO4 is on the top. And from this chemical equation, you can see that 1 H2SO4 reacts with every 2 NaOHs. So it's a 1-to-2 ratio. So that means to neutralize 8 moles of NaOH, I would need 4 moles of H2SO4. Okay, let's look at one more here. So we're going to, this is what we call a Bronsted-Lowry equation that we're going to write here. This shows what it means for a substance to be an acid or a base. So we think of acids as hydrogen donors and bases as hydrogen acceptors. We've got this way of remembering it, BAAD, which is bases accept and acids donate. And what is it they're accepting or donating? Is a hydrogen. All right, so HNO3, this thing right here looks like an acid. I can tell that because it's starting with a hydrogen. And acids are going to be hydrogen givers. So HNO3 is going to give away a hydrogen, leaving behind NO3. And NO3 will have a negative charge now because it was neutral and it lost something positive, so now it's negative. Water started out with 2 hydrogens, it gained 1, now it's got 3, and it started out neutral and gained something positive, so now it has a positive charge. Okay, notice that since HNO3 was my acid, then water acted as my base, because if HNO3 is a hydrogen giver, my water was acting as the hydrogen taker. All right, down here, I've got the carbonate ion, and I've got water. And this thing doesn't have any hydrogens to give, so it must be a taker. So I'm going to say this is going to be my base, and it is going to take a hydrogen. So CO3 becomes HCO3, and -2 becomes -1. And then H2O becomes just OH, and it goes from being neutral to having a negative charge because it lost something. It lost something positive, so now it's negative. And notice that since water was a hydrogen giver, water is actually acting as an acid here. So notice that water can be an acid or a base depending on what it's paired with. It can either give a hydrogen or take a hydrogen. All right, so I'll make another video later on the titration problems below.